Hello students, how are you? Hope you all are doing well. In today's lecture, we are going to do a revision of chapter 1, that is chemical reactions and equations. So let's get started. First of all, we need to understand what are chemical reactions. A chemical reaction is a process in which one or more substances, also called the reactants, are converted to one or more different substances known as products. For an example, I've written here magnesium reacts with oxygen to produce magnesium oxide. With the formation of a new product, a chemical reaction can also be identified with these clues. First is change in state, second, change in color, evolution of a gas, change in temperature, and also there can be change in smell. These things indicate that a chemical reaction is taking place. To write down the chemical reactions, we use chemical equations. A chemical equation represents the reactants, products in formulae and their physical states symbolically. For example, iron reacts with water to produce iron oxide and hydrogen gas. Representations used in chemical equations. State symbols are letters that are added to a formula to indicate what state each reactant and product is in. Four state symbols are like S is used for solids, L for liquids, G for gas, and AQ is written for aqueous solutions. When we write a chemical equation, we need to balance it. A balanced chemical reaction is an equation that have equal number of each type of atoms on both sides of the arrow. Why we need to balance the equation? It is due to the law of conservation of mass, which states that no atom can be created or destroyed in a chemical reaction. So the number of atoms that are present in the reactants has to balance the number of atoms that are present in the products. To write a balanced chemical equation, some tips are given here. Method to balance a chemical equation is, first of all, you need to balance all the metals, then non-metals, then hydrogen atoms, and finally oxygen. For this, you need to identify the metals, non-metals, hydrogen and oxygen and write the number of atoms present in the reactants on one side and products on the other side. Here methane reacts with oxygen to produce carbon dioxide and water. Here carbon atom is 1 in reactant as well as product side. Hydrogens are 4 on reactant side, whereas hydrogens are 2 only on product side. Oxygen atoms are 2 on reactant side and 3 on product side. So first of all, as I have written, we need to balance the metals. As there is no metal present, next we will move on to non-metals. Non-metal is carbon. Number of carbon atoms are equal on reactant as well as at product side. So next we will move on to hydrogen. As we can see, hydrogen are 4 atoms in reactant and 2 atoms on product side. So we will convert them into easy multiples. So as you can see here, we will put 2 in front of water molecule on product side. So now the hydrogen atoms become 4 and oxygen atoms also become 4 on product side, but on reactant side oxygen are 2, so we need to place a 2 in front of oxygen molecule. So now we get a balanced chemical equation. What is the importance of writing a chemical equation? Very important question from exam point of view. It is a shorter way to represent a chemical reaction and chemical equations become more concise and accurate as well as useful. Now we move on to the next topic, that is types of chemical reaction. As you can see on the screen, there are 4 types of chemical reactions: combination reaction, decomposition reaction, displacement reaction and double displacement reaction. Now we will discuss them one by one. So first we take the combination reaction. A combination reaction is a reaction where 2 or more elements or compounds combine to form a single compound. For example, I have written here calcium oxide reacts with water to form calcium hydroxide. So here two reactants are used and the number of products formed here is only one. That is why we call it a combination reaction. Second type of chemical reaction is the decomposition reaction. A decomposition reaction is a reaction in which a compound breaks down into two or more simpler substances. The general form of a decomposition reaction is a compound AB breaks down into products A and B. Most decomposition reactions require an input of energy in the form of heat, light, or electricity. That means a compound needs energy to be broken down into simpler substances. So, on the basis of the form of energy supplied, the decomposition reaction can be categorized into three types. First is thermolysis, second is photolysis, and the third one is electrolysis. Thermolysis means the reaction is taking place by supplying heat energy. Here calcium carbonate is being broken down into calcium oxide and carbon dioxide. Second is photolysis, that means decomposition reaction is taking place by light energy. When light energy is supplied, silver chloride breaks down into silver and chlorine gas. Third one is electrolysis. It is a very common term being used in classes. Electrolysis means by supplying electrical energy. The most common example of this is electrolysis of water. That means water is broken down into hydrogen and oxygen gas. Now the third type of reaction is the displacement reaction. A displacement reaction, as the name indicates, it is one wherein the atom or a set of atoms is displaced by another atom in a molecule. Here, the point to be noted is that only a more reactive metal can displace a less reactive metal. For example, when zinc reacts with copper sulfate solution, then zinc displaces copper from its solution and it becomes zinc sulfate and copper is being deposited on the plate. Next reaction is the double displacement reaction. Double displacement reaction occurs when a part of two ionic compounds are exchanged and make two new compounds. The pattern of a double displacement reaction is like this. For example, if sodium sulfate reacts with barium chloride, a curdy white precipitate of barium sulfate is formed and a solution of sodium chloride is formed. Here we can see both the solutions have exchanged their ions. So these were the four types of chemical reactions. There is one another way. On the basis of energy flow, we can also categorize chemical reaction as of two types. First one is endothermic reactions and the second is exothermic reactions. As we have already discussed, the decomposition reactions are endothermic reactions in which energy is supplied. Exothermic reactions are those reactions in which energy is produced. As we have discussed many types of reactions, we have observed that sometimes oxygen is lost and sometimes oxygen is added to one or more compounds, and same is the case with hydrogen. Here, the point to be noted is that the addition of oxygen or the removal of hydrogen from a compound during a reaction is called oxidation, whereas the reverse, that is removal of oxygen or addition of hydrogen, is called reduction. Combination of both oxidation and reduction taking place together in a reaction, this is called redox reaction. As you can see on the screen, I have written some examples. CuO reacts with hydrogen gas and CuO is reduced to Cu, that is copper. At the same time, hydrogen gas molecule gains that oxygen and is oxidized to water. So here reduction and oxidation are taking place together. So this type of reactions are called redox reactions. The oxidation reactions can produce harmful effects also. The example of this is rancidity. It is a condition in which the substances with oil or fat gets oxidized when they are exposed to air. A substance is said to be rancid when there is a change in smell, taste and color of that substance. An example of rancidity is when a chips pack is exposed to atmospheric air, which results in the change in taste and odor. Precautions which can be taken to avoid oxidation of food or rancidity are: first is food material should be kept in airtight containers. Second, packing of food materials like chips should be filled with nitrogen gas. And we should avoid keeping cooked food in direct sunlight. An important point here is that chips are filled with nitrogen gas. The role of nitrogen is that when it is introduced into a package, it drives out oxygen and any other moisture present. By modifying the atmosphere inside the package, food packaging with nitrogen preserves the quality, slows down the spoilage, and extends the product's shelf life. The second harmful effect of oxidation reaction is corrosion. When a metal is exposed to moisture, air, water, and acid, etc., for some time, a layer of oxide is formed which weakens the upper layer of metal and is said to corrode the metal, and this process is called corrosion. The black coating on silver and the green coating on copper are some examples of corrosion. Corrosion causes damage to car bodies, bridges, iron railings, ships, and to all the objects made of metal, especially those of iron. Corrosion of iron is also a serious problem. Every year, an enormous amount of money is spent to replace the damaged iron. The corrosion of iron is called rusting. There are some ways by which we can avoid corrosion or rusting. First one is by painting the surface of metals. Other is by coating the surface with a thin film of some non-corrosive metal like nickel, chromium or copper. The last one is by greasing or oiling. With this, we finish with the revision of chapter 1. Now let's have a quick recap. Answer these questions in the comment box. First one is, what happens when dilute HCl is added to iron fillings? Second is, what is a balanced chemical equation? Third one is, why is respiration considered an exothermic reaction? And the last one is, why do we paint the objects made of iron? Thanks for watching.